हेलो स्टूडेंट्स। तो आज हम पढ़ेंगे सेमीकंडक्टर्स के बारे में। तो आज मैं कोशिश करूंगी कि ये पूरी यूनिट जो है आपकी कंप्लीट हो जाए। ऑन द फर्स्ट वी नो metals are of three types: semiconductor, conductor and insulators. So what is the difference between all three? On the basis of electrical resistivity, material can be classified into three stages or three categories. First is conductor. Conductors have the very high conductivity and very low resistivity. Its resistivity is in range of 10 की power minus 8 to 10 की power minus 6 ohm meter. You can see the resistivity is very small as its power is in minus. Okay, so as conductor have very low resistivity, it has high conductivity. Examples are its metal, for example copper, gold, silver. That's why we use copper wires in our in an electrical appliances. Insulators are the material which have very high resistivity and very low conductivity. Resistivity is that the property to oppose the current. Okay, so as it opposes, its resistivity is very high, that means it opposes the current very high, so it does not allow current to pass through it. Its resistivity is in positive power, 10 ki power 7 to 10 ki power minus 18 ohm meter, known as insulator. Example of its are like plastic, wood. All most of non-metals are insulators except germanium. Now semiconductor is a material that have properties in between conductor and insulator. Its resistivity is semiconductance, means lies between the range of conductor and insulator resistivity. Its example is silicon and germanium. These are the two important examples. Silicon and germanium, which is used in electronic devices, mostly used in electronic devices. Temperature coefficient of resistance of conductor is positive, means temperature coefficient positive means while increasing in temperature the resistance increases. Okay, resistance increases with increasing temperature. Here is the formula, that R by temperature. R is resistance, T by temperature. So as we increase the temperature, resistance is also increases. That means alpha is positive. Alpha is temperature coefficient. So conductors have a positive temperature coefficient, while semiconductor and insulators are negative temperature coefficient. As we know, why silicon and why semiconductors and insulator have negative temperature coefficient while conductor have positive temperature coefficient. So as we know, as we increase the temperature of the material, the electron can gain high energy from temperature, and due to thermal runaway or thermal emission, the electron get ejected out from the metal surface, and they become free. They come out from their atoms and they become free, and electric conductivity starts. But in case of conductor, we already have free electrons. Try to visualize that we have an insulator or semiconductor, as both are working same with temperature. Suppose we have a semiconductor in which electrons are bound in atoms. As we increase the temperature, if the energy there is greater than work function, electron get emitted out from atom, and they start moving and they contribute in conductivity. That means conductivity increases with increase in temperature. But in case of conductor, we already have free electrons, and when we increase the temperature, they start colliding with each other, and when they collide with each other, their freely movement decreases. That's why temperature coefficient of it is positive, while both semiconductor and insulator have negative temperature coefficient. Now we have studied about the resistive properties of semiconductor. Now let's study more deep about semiconductor as our unit is based on it. So first of all, intrinsic semiconductor. Semiconductor we know which have properties lies between conductors and insulator. So first of all, intrinsic semiconductor or pure semiconductor, sometimes we say, what is that? Silicon semiconductor crystal has tetrahedral structure. Tetrahedral means it have four electrons in its valence shell. Suppose we have an atom, it have four electrons at its outermost shell. Okay, or we can say its valence is 4. So that's why it's called tetrahedral structure. It has tetrahedral structure. Tetra means 4. In these, it is a structure of silicon and germanium. We know silicon and germanium both have 4 electrons in their outermost shell, and the whole line of in periodic table which have 4 electrons in their outermost shell is semiconductor, except carbon. Okay, because carbon is of very small size, and all its configuration lies in s orbital. So as we know, s is very close to nucleus, first orbit is very close to nucleus, so it takes large amount of energy to emit out the electron, and the energy to take electron out is very large in case of conductor. So it be carbon in carbon, if we try to remove the electron from its atom or from its shell, it require large amount of energy, and this energy is very large. That means carbon is act as an insulator. Okay, carbon act as insulator. So, but the next to carbon is silicon, and then next to it is germanium. These both are a very they both play very important role in our electronic devices, as they have four electrons in their outermost shell. So they make covalent bond with each others. Okay, they made covalent bond with their neighbor atoms. ठीक है? A covalent bond, we know covalent bond is sharing of two electrons shared by two atoms. At all absolute zero, all valence electrons are present in covalent bond and no free electrons are available for electrical conduction. That means at zero temperature, no electron will move, all are bounded in their covalent bond, and no conduction is possible in even in semiconductors. That means they behave as a perfect insulator at absolute zero. Why? Because at absolute zero all the electrons are bounded together. Okay, like this you can see this one electron from silicon, first electron from silicon, this one silicon, and the second is from another silicon atom. Now they are bounded. As they are bounded and no temperature is there, no at the absolute temperature, they won't move, or they are bounded in their atoms. So no conductivity is possible, and they behave as purely perfect insulators. But if we rise we rise temperature, these electrons start moving, they break bonds and they become free, and they start moving, and these moving electrons contribute in making current, and this is the behavior of conductors. At above 0 degree temperature, atomic vibrations start, vibration in electrons, and the bonds get break. Okay, what I have already told you. These electrons and holes are free. As we know, the bonds are broken. The electron get ejected out from the atom or valence shell. The holes are created. Suppose if this is the electron and I take it, it got ejected out from its metal, then the rest position of it is hole. Now its hole is also contribute in conduction. Okay, both holes and electrons contribute in conduction. So as these electrons and holes are free and able to move as a conductor insulator, the energy required to make free an electron is Eg. The minimum amount of temperature or the minimum amount of energy by any means is Eg, that it break the bond or it can eject out the electron from the bond. The energy Eg is not accepted and will not make free the electron from valence band. When electron become free, it will be in conduction. That means, what is telling, if the energy is less than Eg, the electron lie in valence band, or valence band means the electron is bounded. But if the energy is equals to Eg or greater than Eg, then the electron suddenly get jump to the valence band. Valence band to conduction band. Here is the conduction band. Conduction as by name, which donates in conduction, the electrons become free. At the amount of energy required to get the electron eject out from its bond is Eg here. Okay, the amount of energy is Eg. Now if the energy is less than that Eg, the electron will stay in its bond. Okay, but if the energy is greater, the electron get eject out. But electron cannot stay. If suppose if the energy is in between, still the electron lie in valence band. That's why we call it the forbidden energy gap, because the amount of energy that is less than conduction band is forbidden. We can't see that energy even if we provide, suppose it is 100% band gap, and if we provided 50% energy, the energy get forbidden. We cannot see the electrons coming out from valence to conduction. That's why we call it the forbidden energy gap. The theory is written, what I already told you. That is why we call it the forbidden energy gap. When its covalent bond breaks, electrons and holes generate in pair and known as electron hole pair. When suppose the bond breaks, there's pair generated, that is one is electron and another is hole, that we call it together is electron hole pair. Therefore, the construction of free electron and hole will always be equal an intrinsic semiconductor. That means, what is saying it is saying that number of electron will always equals to number of holes, because we know if the bond will break, it will produce two things, that is hole and electron. And if there are n bond breaks, there are n holes, there are n electrons. Okay, there is no such kind, like holes are greater than electron or electron is greater than hole. No such things in pure semiconductor. That's why we call it intrinsic semiconductor, a pure semiconductor, because no impurity in it. All atoms are of silicon. Since carrier are available now, intrinsic semiconductor has some conductivity for electric current, but not electron hole pair generation, only depend on temperature. Hence, conductivity of intrinsic conductivity is depends on temperature. That means if we have semiconductor, it conducts, but we try to increase its conductivity. How can we increase the conductivity of pure semiconductor? Temperature, only by temperature, because we know as we increase the temperature, number of bond break will increase, and number of bond break increase. That means number of electrons are free, more free. Number of electrons are greater. If number of electrons are greater, that means more conductivity is there. So the only method to increase the conductivity of pure semiconductor is by temperature. So but the temperature is not in our hands. Okay, so that's why, but because at a large amount, like in homes or in these area, how we can control the temperature? We can control in our lab, but not at people's home. Okay, so we it's also like why can't we make a device which work on the normal temperature? Okay, so let's study this. Okay, the only the only disadvantage in pure semiconductors is that their conductivity is low, because its conductivity only on depends on temperature. We cannot change its conductivity. Okay, its conductivity depends on temperature, and we have nowadays a extrinsic or impure semiconductor which have very high conductivity. So we never use these, but just to study we study pure semiconductor, but we don't use it in a real life, because what is more efficient devices. But in it, as we know, number of electron equals to number of holes, and the number of electrons is denoted by n, and number of holes is denoted by p. Both are equal, we can say n. I is for, I subscript is for intrinsic. Okay, as no n barabar ni and p barabar ni, both are equal. That means their multiply equation 1 and 2, n and p is equals to ni square. This is known as mass action law. Okay, this is known as mass action law, that np is equals to ni square. Concentration of charge with temperature by relative ni equals to a naught t square e की power e kbt upon kt, where this is a formula what is telling about the number of electrons created by temperature, or it depends how many number of electron will eject out by increasing the temperature or by band gap. Well, band gap does not play the important role, or it does not, but still in a formula that is written here, it connects the temperature and bond breaking. In intrinsic, there are the reason that intrinsic semiconductor is not suitable for semiconductor devices, making these are, as we already studied. In intrinsic semiconductor, number of electrons equals to number of protons, or number of holes, sorry, number of holes. This is not derivable for semiconductor devices. Instead, it should be either n greater than equals to p, or p greater than equals to n. Conductivity of intrinsic semiconductor completely depends on temperature, not on forbidden, not any external observable, or not any quantity. Conductivity of intrinsic semiconductor is least at non temperature, रूम टेम्परेचर पे कंडक्टिविटी इनकी लो होती है. Extrinsic semiconductor. Now switch your mind to extrinsic semiconductor. These are the most useful devices in our nowadays. What is are they? They're extrinsic semiconductor. As we know, pure things don't lie nowadays. Everything is impure. In our surrounding, we can see that everything is impure. So now we use impure semiconductor, but now the impure semiconductors are best rather than pure semiconductors. They are cheap, and their durability is high there. We can change its conductivity, resistivity, and all the parameters. Extrinsic semiconductors are made by adding impurity and intrinsic semiconductor. Yani we add some impurity to a pure semiconductor and it becomes impure. This process is called doping. That means control amount, adding adding impurity in control amount is doping. Like it does not mean we add too much. We just add small impurity atom to semiconductor, and the atom can be of group 3 element or atom can be of group 5 element. Group 3 means atom which, which have 3 electrons in their outermost shell, and the atom we had which have 5 electrons in their outermost shell. Okay, so these are the external, or we can call sometimes impurity we add in that group 3. Or group 3 means the atom which have 3 electrons. Okay, like or the atom which have 5 electrons. Yeah, like group 5 element we call sometimes it. So it's the lows we okay, impurities added to sample like these, as you know the group I already told you the group 3 and group 5 we add here, but if we add group 5 element in the pure semiconductor, it becomes N type. Why it becomes N-type? Because we adding the impurity atom, this atom has 5 electrons in its outermost shell, but the silicon have 4 electrons in their outermost shell. So when they bound, as we know the all structure is of silicon, we add just one atom of other atom. Okay, we add just one atom of phosphorus or maybe it any group 5 element, both make covalent bond. Four electrons get in bond, but the one is still there. Like there are four semiconductors. Okay, here it have four bonds. It also have four bonds, but the added impurity have five bonds. So five electrons. Added impurity. This like this added impurity has five electrons in their outermost shell, but the silicon has four only, so it will make a bond between four electrons of both, but one is still left because of external, and this electron play very important role in conduction because we have electron even at zero temperature we have conductivity because of this zero temperature, some current. Now if we increase the temperature, the electron also get break bond, but still there even when the bond breaking is not start, we still have those electron in the atom or in a structure which contribute in conduction. We already have electrons in starting, which when we increase the try to increase the temperature, they start moving, current increasing continuously, not discontinuous or any point. So this is all about N-type semiconductor. Now P-type semiconductor is also same, but here the vacancy of electron. And like P-type group 3 elements, they have 3 electron in the outermost shell. Silicon have 4 electron in their outermost shell. They make covalent bond, but one hole space of one electron is left. This is called hole, and this hole also contribute in conduction. Okay, so this is about electrons. Now, the next we will discuss in the next video. Stay tuned to our video, stay tuned to our channel. Thank you.